And is this slide visible or not? Good, thank you. So let us begin with the fourth unit, which is with regard to including some procedural concepts, paradigms into our SQL. Whenever we include a particular procedural concepts or paradigms into SQL, it is called as PLSQL, procedural language with SQL. It is not programming language. It is procedural language with SQL. So you need to be very clear with the synonym over here. What is its elaboration? This is again an interview question. If you spell it wrong, they will just try to ignore you. Okay. So here PL expands to procedural language, but not for programming language. So let us try to understand what is the outline of this particular unit, fourth unit, what we are going to learn. We are going to understand what is the architecture of PLSQL. Then we will try to understand at least 5 features of PLSQL and explain the data types. Then try to have some naming conventions to be learned whenever we try to declare some variables. Then we will try to understand what are the pre-built functions available with us provided by the PLSQL developers to us. Then, like SQL, we created some tables. Like in SQL, how we created few tables. There are certain tables which we can create using PLSQL. How those tables will be created and what will be their structure, we'll try to understand. There in the SQL part, we call the tables each and every row or as an entity or a row. Okay, but here in case of PLSQL table, we'll call each and every row here as a record. So how to create a record and then how to create a table out of those records, we'll try to see those things. Then we'll try to understand what are the programming paradigms included in PLSQL. How does a procedural language with SQL supports the decision-making functionality of a programming language? Then what are the various looping statements available in case of our PLSQL? We'll try to understand what is exception handling and try to see a few programs around it. We'll try to see what are the built-in exceptions which are provided to us, which we can use and work around with our programs so that our programs can work without stopping or getting halted. Then we will try to see how do we create our own user-defined exceptions, what are the advantages of it. Then we will try to see what are the features of the exception handling mechanisms. Then how do they propagate? If I have got 10, 15 exceptions in a program, then which exception will be called first, then what, like that. How that propagation goes on. Then what is a subprogram? How do I create a small program like our script in JavaScript and store it in the memory so that those subprograms can be utilized in near future. Then we will try to understand what are the procedures and functions, what is the difference between them. We'll try to see with regard to the parameter passing methods, like that of your C and C++, you were having two types of parameter passing. One was call by value, second was call by reference. Here there are three types of parameter modes. We'll try to see what are those modes. They are very easy. If I want to give a default value to a particular parameter, to an argument, how do I give the default value? Then we'll understand what are global, local, and system variables. By that, I hope we will finish with that particular recursion coming in between. Okay. So with the recursion, we'll close off our fourth unit. So let us try to understand what is PLSQL. PLSQL stands for Procedural Language Extension to the SQL Structured Query Language. Oracle has basically introduced this PLSQL concept for all the developers to directly interact with the SQL. What used to happen earlier is some programming language used to cooperate with SQL and they used to execute the query of SQL there. For example, I am telling, we were learning Java, right? Java programming language include a package called as java.sql, which was containing all the supportive files and methods, classes, which were required to interact with the Oracle's SQL or MS SQL or your Microsoft SQL or MySQL. So it was containing a huge number of programs which were trying to give a bridge between our Java program and the SQL language syntaxes. So whenever any program was written, which was composed of Java programming concepts as well as SQL part, Java compiler with the help of java.sql package used to segregate what lines are meant for SQL and what lines are meant for Java compiler. The lines which were of Java's part were compiled by the Java compiler, and the lines which were meant for the SQL part were given for the SQL engine so that it gets executed. Now this SQL engine will be present at data server, right? So it has to be sent from our machine where we were trying to develop the software to the SQL server machine, and it used to get compiled and the result used to come back, and we used to incorporate that result in our Java program. This was a lengthy and little complex part, little complex. Though Java has made it very efficient, very short and very efficient for us to use, but it is still a complicated procedure. Oracle said, why do you write a program in another language? Why not in the Oracle's language itself? So the program can be directly running on the server and it will be executing neatly on one single compiler itself. No need of Java compiler and then on to Oracle's server. So procedural language was incorporated in Oracle just to support all the programming terminologies and concepts and paradigms so that they can be used efficiently on the SQL server. So that was the motive behind the extension of SQL with regard to procedural language concepts. Now, the language, that's all we talked about, right? So what is the actual thing that is making us to learn this particular procedural language? The first and foremost thing that we should remember is whenever we are trying to interact with any language, we need to interact in its terminologies. In its terminology, in the sense, suppose a language is there which declares a variable of integer type, but that integer type takes 2 bytes. And suppose another language is there which takes integer as 4 bytes. Then the interaction between the 4 bytes to 2 bytes will be a little difficult, because if 4 bytes of integer data is there, let us imagine that huge number is there. And if it is being converted into 2 bytes of integer number, then there will be definitely 2 bytes of loss of data. So whenever we are trying to interact with any language, one language to another language, the languages should be compatible. Compatible with regard to their terminologies, compatible with regard to their data types, compatible with regard to their particular statement structures, compatible with regard to their way of accessing of data, compatible with regard to their way of making function calls, and all those which are required for a particular application to interface between two languages. Okay, so for any host language which includes the SQL component, it was becoming very difficult for them to have all these matching features. Whereas in case of PLSQL, you will have all those data types which were there in SQL all included back in PLSQL. You will have all these statements which you used to write in SQL will also work in PLSQL. Whatever results were given back to you using using SQL, when you have written the select statement for retrieving the data from the table, let us say select star from EMP, employees table, it used to give up a particular data containing a number of rows and number of columns. That huge amount of data was not in just one variable format. It was in the structure of a table. So that table should be able to be stored back in some variable format in procedural languages. That capacity is also there in case of our procedural language. Whereas in case of Java language, you can put only one variable, not the whole table as it is. So that's again a problematic part for the host Java language. So procedural language provides all these features to us, because of which we are mainly trying to learn those things. Okay. So whatever data types are there in PLSQL, they are actually a superset of those data types which are available in our SQL. So remaining points are not so important. The only thing that this point is talking about is whatever business logic we have got. Business logic in the sense whatever computations we wanted to do in our program, we can do it with regard to with the help of our procedural language. Okay. So how does it interact with? Whenever SQL is to be executed, do remember whatever application you are using for running the SQL, application, let us say whatever black window we have seen, in which command prompt we have seen, in which we have typed our commands, if you recollect back, that black command prompt was called as SQL star plus, right? In that SQL star plus, whatever we wanted to compare, execute, it takes only one statement at a time and executes it. But it will not take a bunch of statements and execute them in one single go. So even if you have got multiple SQL statements that are to be executed in SQL star plus, if they are to interact with our database, SQL star plus is just an interface application. It takes that command, sends it to the database engine for execution. Whatever result is being popped up, it will be retrieved back by that particular application and displayed back to us. That's all work of your SQL star plus, right? So if you have got multiple SQL statements to be executed here, those SQL statements will not be executed in one single attempt. Only one single SQL statement will be executed at a given moment of time. Okay? Not bunch of them at a given moment of time. Whereas in case of PLSQL, it will execute a block at a time. Block at a time in the sense, a block may contain multiple statements which are related together. So we can send one block of code to get it executed in PLSQL, and that block of code will be passed on to database, and that database will perform them one after the other and return back the result. So we can perform some concurrent execution of multiple SQL statements in PLSQL. And also, in SQL, whatever predefined functions were there, we were able to use only those predefined functions only. Whereas in PLSQL, we can define our own procedures as well as our own functions, and we can create our own packages, we can create our own libraries, we can create our own triggers which we can execute from our own side, apart from what are already defined up, predefined. So why, though we have learned SQL, we are still trying to learn what is PLSQL. Clear? What is the difference between SQL and PLSQL? What is the architecture of PLSQL? PLSQL, whatever program you try to write, will be containing two components. One is SQL part of the statements which you have incorporated in PLSQL. Second is the programming language concepts which you have incorporated in our PLSQL, procedural SQL. So PLSQL block will be composed, whatever code you are going to write, whatever program you are going to write, that program here is called as block. It's called as what? Block. That program code will be called as block. This is the terminology difference between different languages. Okay. So this PLSQL block will mainly be composed of SQL statements as well as PLSQL units. Units in the sense, like for example, in the procedural language, we will have some decision making statements like if else ladder, for loop, while loop, all those concepts, paradigms of a particular procedural language. Clear? These two will be given for the PLSQL engine. So what does PLSQL engine will do is, it will try to segregate what is the SQL part and what is PLSQL part. Once it has segregated what is SQL part and PLSQL part, it will not run this SQL by itself. PLSQL engine will only look for what is the PLSQL units or paradigms that are available in our program code, and it will be given for PLSQL unit executor. This PLSQL unit executor, if any values are to be used from the SQL's result, then it will wait for the SQL to fetch the data from the SQL executor and get it from the database. Is it fine? So once the data is retrieved, it will be given back to the PLSQL executor so that it can go for the next execution lines. So this is the entire architecture of your PLSQL part. Is it clear? Now, how many components are there for your PLSQL architecture? One is the PLSQL block, second is the PLSQL engine, third is the database server. Third is the database server. Do remember, SQL statements will be executed only and only on database server. Do remember this part. Database server will not execute your PLSQL block of code. This PLSQL block of code will be composed of SQL statements and PLSQL program units. Your PLSQL engine will segregate them into SQL part and PLSQL part. PLSQL part will be executed by the PLSQL engine with the help of PLSQL executor. SQL part will be given for the database server, which will execute it with the help of SQL executor. So these three components are there in case of your PLSQL architecture. Now what exactly is your block going to contain? What diagram I have presented here, block diagram, whatever I have presented here, some of the textbooks have used this particular diagram for representing the same. It's the same concept. Whatever PLSQL program you have written, that PLSQL block will be separated into SQL part and PLSQL unit parts, and that units will be given for the procedural statement executor or PLSQL executor, and SQL part will be given for the SQL statement executor, which is a part of your database. Same diagram. So whichever you feel better and convenient, you can learn from that one. You can draw that one. Okay. So what exactly will be our PLSQL program or code look like? This code will be composed of some sections. Sections in the sense, each section of the program will perform a specific task. The first section will be the section which will contain the declaration of variables, just like in your C language. First you need to declare variables, right? Same way in PLSQL, first you need to declare whatever variables you are going to use. Whatever variables or procedures or something like that, whichever you wanted to use, you have to declare them first. That part of code is called as declaration section. Second part of code, which will be the main one for us, will contain the number of statements which we write for making up our program, in which we have included our entire logic. That block which will contain the actual code which is to be executed is called as execution section. Then the third block will be there, which will contain while the program is being executed, if any error happens, which is an expected error and which can be handled easily by the programmer itself, then that error, what is to be done, how it is to be handled, will be returned in the exception handling section. So how many sections we have learned? Three sections. First one is the declaration section, second is the execution section, third one is the exception handling section. Okay, again I am repeating, declaration section will contain those type of statements which are usually meant for declaring of variables, or some, if you wanted to have some methods to be defined, some procedures or functions to be defined, then you can use that particular section for declaration of those things also. Second section is the actual code which we'll write to implement our logic of our program. And the third section will contain the code which will try to check if any error happens in the second section, in the execution section. If any error happens, what is to be done to handle that particular error such that our program doesn't terminate abruptly. That last section, third section, is called as exception handling section. So clear with these three sections now? Whatever three sections we have segregated, PLSQL treats it as one single block only. Treats it as one single block of code only. Do remember this part. And one more thing. Sometimes you will write a program, and that program, if it is good enough, you will give a name to that program so that you can use that program again by calling that particular name, calling with that particular name. Okay. Sometimes you will write a particular program which may not be of very highly useful for you, useful nature for you in near future. So you will not name it by any name. You'll just write it once, execute it, and when it has been executed, your program has finished. It is not stored in the memory permanently. Okay. So we have got two categories of programs now. One is the one which we are giving a name and saving in the memory so that in the near future we can use them. Second category is the one which we don't expect to be used in near future. We think that only it is required at this particular stage of time, and we will try to write that particular code and execute it. Once that execution is over, our program will not be stored back in the memory permanently. Okay, so the first one, which is being stored permanently, is called as stored subprogram. Is called as stored subprogram, and the one which is not being saved permanently is called as anonymous block of code. Anonymous means something which has not been given any name. Anonymous means nameless, actually, right? So we have got two blocks of code. One is the stored program. Second is anonymous block of code. So again, within the stored and within the anonymous, we have got various other categories, which we will learn little later. So one is anonymous block of code. Second is in the stored category. When you are giving a name to a particular program, that name may be a function name or maybe a procedure name. Procedure and function combined together, if those related functions and procedures, they are combined together, suppose 10-15 functions were there and 10-15 procedures were there which were working around one single topic, then those will be combined together to form one library. And this library is basically composed of various packages which were built using the procedures and functions. In packages, we have got two sections. One is body section, another is specification section. When the package last unit comes, we'll learn those topics. Another is a type of code which will be running always in the background and checking whether a particular event has occurred or not. If any event has occurred, that particular program will get executed automatically by the Oracle engine itself. And that program is called as a trigger. If you want to create any data type by your own side, then you have got a keyword over here called as type. Just like in C++ and Java, if you wanted to create your own data type, you used a keyword called as class. You started defining a class, right? Same way, we have a keyword over here called as type, using which we will define our own data types. Then what is the body of the type? So these 9 blocks of codes are the different types of PLSQL units. Okay, you should memorize them. Let us revise back. Anonymous block of code, functions and procedures, related functions and procedures combined together to form package. Okay. Related packages combined together to form libraries. Related programs which will wait for an event to occur, and based on the event's occurrence they will get executed. Triggers, a keyword which will help us for creating our own data types called as type. All these combined together will form a particular PLSQL block of code. These are the different types of PLSQL units. So, I've written some more theoretical points describing this particular diagram, which you can use for writing in your exam. Do you remember? Explain the architecture of PLSQL engine, or we can say explain PLSQL architecture as an important question. So what are the features? First feature is that PLSQL is tightly integrated with SQL. It's built on top of SQL itself by the same server. It gets run on the same server. So it will be very tightly integrated. Integrated in the sense combined together, linked together. It offers extensive error checking. There are lots of predefined exception handling mechanisms provided by the PLSQL developers to us. It has got various numerous data types which help us to easily work around with our program. It has got all the programming terminologies which we have learned in C and C language mostly. We have got two things over here. One is the functions, second is the procedures. What is the difference between functions and procedures? That's a very simple thing which we'll be learning shortly. Then it also supports object-oriented features of our programming languages. Then if you are a good developer, program developer, instead of writing program using some host language such as Java or C++, you'll write program directly using PLSQL. But there is one condition. This PLSQL should be supported by your database server. If it is not supported by your database server, then it will not help you out. For example, in case of Oracle, you have got built-in facility provided and PLSQL engine has been provided to you. Whereas in case of other database servers, that built-in capacity is not there. Next, just like your Java program, which was platform independent, once you compile your Java program and generate a bytecode file called as whatever file name dot class, that class name you can copy into any operating system environment and you are able to run it on that particular operating system environment. That's called as portability. That feature of that ability to copy your bytecode file onto any operating system environment and execute it in that environment is called as portability. It is called as what? Portability. Now, PLSQL is also completely portable. Once you have developed a program, PLSQL program onto Linux operating system, let us imagine, you have compiled your code on Linux. You copy the compiled file onto Windows operating system, it will run exactly the same. There will not be again a need for you to type the code on Windows operating system and then execute it. There is no requirement. Okay, it is completely portable and it is going to have very high performance transaction with regard to your database because it is just built on top of database itself, right? You have got all the built-in interpreted and OS independent programming environments inside your PLSQL. PLSQL can be executed from the same command prompt which you have used for your SQL commands to be executed. That means it is not going to require you another compiler or another utility to interact with our programs. Single utility will be enough for us to run our programs. Now, okay, we are writing the programs using PLSQL. Suppose there comes a need where I have to execute these PLSQL programs from another programming language. Just as how we included SQL into another programming language, host programming language, can we include PLSQL into another host language? Yes, you can do so also. That's another feature. Now, one of the beautiful things which made PLSQL easily accessible and easily adaptable in the programming scenario, in the programming world, Unity, is its syntax. Syntax was very similar to already existing programming languages at that particular age of time. The languages which were highly adaptable were Ada and Pascal. So PLSQL syntax is different from your C and C++ syntax. It's not the same. So is the Oracle the only one which is providing PLSQL, supporting PLSQL? No. IBM also supports it. Okay, IBM has got its own database called as DB2 database. Using this DB2, it supports this PLSQL feature. So what are the advantages? Again, I have written it back so that you can write it in your exams. So please go through these advantages of PLSQL. Whatever we have discussed, almost the same concepts have been written back with some terminologies being different. Okay. So let us try to understand the same thing, differences that were asked multiple times in your examinations. What is the difference between PLSQL and SQL? Once we have learned SQL, why do we need to learn PLSQL again? So all those things which we discussed earlier has been kept over there. So here I kept those three sections in front of you. This structure of your PLSQL block of code. This structure will contain the declaration section. From here, your execution section is going to start and end. Then from here, exception section is starting. This end keyword will signify with a semicolon, signify that your program itself has finished. So we don't have any curly braces, all that stuff. We don't have curly braces here. Clear? So those who are getting upset with that particular curly braces errors coming in between, they can feel happy. But practically speaking, I have got habituated to those curly braces. It makes our program pretty good. So it depends on our logic. How do we write? So here I have kept one program as a sample example program. Altogether, how many sections were there? Three sections. Declare section, execution section, and exception section. Declare section will start with the keyword declare. Execution section will start with the keyword begin. Exceptions section will start with the keyword exception. And lastly, you will end your entire program with the end keyword with a semicolon. Okay. Now, in this particular program, I am trying to have one variable called as v underscore variable, some name I have given. And I am declaring it as of type varchar of 5 characters length. Just like your normal C language, you are closing it with a semicolon. Now, our execution section starts with a begin. Begin. What can I write in this particular execution section? I can include either the SQL statements or I can include any programming terminologies, right? So what I'm trying to do here is I'm trying to use SQL statement. I'm writing select whatever column you wanted to read the data about, that particular column will be listed. But this value, I'm telling it to be not put it back on the screen. Usually when you type select command in your SQL startless, it will retrieve the data and put it back on the command prompt. That is not what I am looking for. I am looking for reading the data into a memory location represented by the variable name. Okay, so I am telling select that particular column name value into this variable name, so that once the value is saved inside this variable, I can use it in some programming terminology. Clear? From which table? The table name you have to give. So what do we understand from this select statement? If you just forget about the second line of this select statement, isn't it the same SQL statement which we run earlier? Select column name from table so and so. This was the normal SQL statement. When it comes for PL/SQL, you will not put the data back on the SQL star prompt. You will keep the data into your memory location, so that whatever memory data you have read from the table, you can use it into your programming terminologies. Clear with this concept? Now, exception. When so and so type of exception happens, the type will be represented with a particular name. Okay? When is a keyword. When so and so exception happens, then what to do will be mentioned here, and then closing of our program. This is a basic overview of how our PL/SQL programs will work. Now let us try to understand which blocks are mandatory, which blocks are optional. Declare block is optional. If you have got any variables being used, then you will use declare. Even declare keyword itself is optional. If you don't write it, there is no problem. If you directly declare the variable, it will accept. But as a good programming practice, you have to always use that keyword. Begin keyword is a mandatory one. Begin keyword is a mandatory, compulsory. You have to use it. Exception keyword and exception block itself is optional. If you have got exception handling mechanism to be included, then you will include it, otherwise it's optional. End is compulsory. Yeah? So, I hope, I don't know how much time is left out now. It's about to be 10:30. I hope within 1 minute or so our program will, our session will wind up. So in the next session, we will be looking into what are the data types that are available, and we will try to understand them. Okay. Here, is there any doubt for anyone? Shall we rejoin back at 10:30 or 10:35? How will we know that this exception is going to happen? Uh, how do we know that this type of exception will happen? This question will be answered with your experience. As you become a good experienced developer, you can think that this type of exception may happen, this type of error may happen by a particular user. For example, you have written a program for addition of two numbers. What is the guarantee that the user will enter only numerical values? You have written enter the value of A. I have typed ABC. Again, you have given enter the value of B. I have typed C. What should be the end result? So there may be a chance that non-numerical values may be entered. Clear? Same way, we are trying to open a particular file so that we can read the content of the. What kind of error may happen? The file may not be even existing. Okay. So if the file is not existing, should our program be halted abruptly? Should it get stopped from execution? No. It should give a proper message back that the file is not existing. Similarly, in the addition program, it should give a particular message telling that please provide numerical numbers for the input values. Non-numerical addition cannot be performed. So with your experience, you will try to assume what type of errors may happen and what to do when such type of errors occur. Sometimes those errors you can handle, right? Sometimes there will be some type of errors which you cannot even handle. For example, the program was running and the hard disk crashed. Can you do anything? No. The program was running, the operating system became halted. Can your program do anything with that regard? No. The program was running, suddenly power failure happened. Can you do anything with regard to that one? Can you handle anything to overcome that halting? No. So there are certain category of errors which you cannot handle, and there are certain category of errors which you can handle. So those type of errors which you can handle are called as exceptions. And the ones which we cannot handle are called as errors. Are called as errors in plain English. So this point was actually a part of exception handling mechanism, which we will see later on. Pujita, is your doubt clear now? Good. So we have got another class waiting for us at 10:35. That is only 1 minute left. So please quickly log out and re-log in using that particular link.